You've probably seen those crazy headlines, right? Giant cargo ships on fire, thousands of cars just gone. And with more and more EVs being shipped every single day, you gotta wonder, are these things basically ticking time bombs out on the ocean? Well, let's get into it.
Yeah, it's the big question, isn't it? Everybody's asking it, from the folks captaining these huge ships all the way to you, maybe thinking about buying an EV. Are these batteries, the ones powering our green future, actually a huge danger at sea? The answer? Well, it's way more complicated and honestly way more fascinating than just a simple yes or no.
Okay, so let's just cut right to the chase here. The biggest myth, the thing everyone seems to think, is that EVs are just constantly catching fire on these ships. But you know what? The actual data, it tells a totally different story. It's not that they're happening more often, it's that the kind of fire is completely different.
And this is where it gets really interesting, because the stats just blow all that hype out of the water. When you look at the numbers, EV fires on ships are not happening more often than fires in regular old gas-powered cars. Nope. Groups like the European Maritime Safety Agency have looked into this, and the frequency is pretty much the same. So again, the story here isn't about more fires at all.
All right, so if that's the case, if they aren't catching fire more often, then what's the big deal? Why all the panic? Why are all these new rules and emergency meetings happening? Well, the answer gets down to the chemistry of a lithium-ion battery fire. And honestly, it's pretty scary stuff.
So, it all boils down to this one terrifying phrase: thermal runaway. Look, this is not your average campfire. Think of it like a chain reaction that just won't stop. It's a violent chemical meltdown happening inside the battery itself. And here's the kicker. Once it gets going, it actually creates its own oxygen. That makes it almost impossible to put out with traditional methods. We're talking insane heat, clouds of toxic gas. It's literally a fire that fuels itself.
And just to put that into perspective, the difference in fighting these fires is, wow. I mean, a normal car fire, you might need, say, 4,000 liters of water. But an EV and thermal runaway, you could be looking at 10,000 liters, maybe even more. It's a completely different ballgame for the firefighters. It's just a whole other level of problem.
So that leads to the next question. How in the world is the global shipping industry, an industry built around gasoline engines, remember, supposed to handle this new reality? It really is a race against time, because right now, they're kind of making up the rules as they go. And to really get it, you've got to look at the regulations. The main safety rulebook for ships, it's called SOLAS, was written way before anyone was even thinking about shipping EVs. So what does that mean for today? It means the entire industry is working off a bunch of voluntary guidelines. It's like a patchwork quilt of rules, while everyone waits for the big international authority, the IMO, to come out with mandatory rules, which, by the way, we're not expecting to see until 2027.
So with no official rules yet, a bunch of the big players have had to step up. You've got groups like the European Maritime Safety Agency, the insurance companies who have a lot of skin in the game, obviously, and these other technical bodies. Together, they've basically cobbled together a set of best practices that have become the unofficial rulebook for how you safely ship an EV right now.
But don't get me wrong, the industry isn't just sitting on its hands waiting for 2027. No way. They're actively building this whole multi-layered defense strategy. It's all about using smart planning and some pretty cool new tech to get ahead of these fires.
And you can boil that whole strategy down to 3 really simple but absolutely critical steps. 1. Prevention. Stop the fire before it even thinks about starting. 2. Detection. If one does start, you need to know about it instantly. And 3. Suppression. You've got to have the right gear and the right know-how to shut it down fast.
All right, so let's start with prevention, because that's your best bet, right? An ounce of prevention and all that. This is about the basics. Checking used EVs for any battery damage, because that's a huge red flag. Making it a hard rule. No charging cars while on the ship. And just being smart about where you park them. Keeping them far away from vital spots like the engine room.
And this next one, this is a huge deal. It's all about the battery state of charge, or SOC, basically how full the battery is. The recommendation is to keep it in this sweet spot between 30 and 50% charged. Why? Because it just drastically lowers the amount of energy that could fuel a thermal runaway. It's such a simple idea, but it is incredibly effective. Okay, but let's say prevention doesn't work. Then it's all about catching it early. And the tech they're using now is pretty wild. We're talking thermal cameras that see heat, special sensors that can literally smell the specific gases a battery gives off right before it goes bad, and even AI watching the CCTV cameras ready to spot trouble faster than any human could. And that speed is everything, because that thermal runaway process can start at just 60 or 70 degrees Celsius. To give you an idea, that's barely hotter than the inside of a car on a sunny day. So your window to actually do something about it is tiny. Catching it early is literally the difference between a small problem and losing the entire ship.
And that brings us to the third step, putting the fire out. And yeah, this is way more than just grabbing a fire hose. Crews need special gear like these heavy-duty fire blankets that can smother a car. They need full-face masks to breathe through the toxic smoke. The ships themselves need things like massive sprinkler systems or the ability to flood a whole deck with CO2. But most important of all, the crew needs to be trained because they're fighting a fire that breaks all the old rules.
So when you look at all these new tools and rules, it kind of forces you to step back and ask a much bigger question. Are we just putting Band-Aids on a system that was never designed for this kind of cargo in the first place?
I mean, think about it. These car-carrying ships, they're basically giant floating parking garages. They have these huge open decks. It's fantastic for driving thousands of cars on and off quickly. But for stopping a fire, it's a nightmare. It's like an open-plan office for fire. It can just spread from car to car with nothing to stop it.
And you know who's watching all of this very closely? The insurance companies. Of course they are. They're the ones writing the massive checks when these ships go up in flames. So they're pushing really hard for better safety systems. And they're sending a pretty clear message. Adapt, or your insurance premiums are going to go through the roof. And let's be honest, nothing makes people change faster than money.
And it's a sad truth, but it often takes a huge disaster to really get things moving. Those really public, really expensive fires on ships like the Felicity Ace and the Fremlin Highway, they were a massive wake-up call for the entire industry. They put a rocket under this whole conversation and made getting new, mandatory rules a top priority. Which brings us to the final and maybe most important question of all. It's pretty clear that EVs themselves aren't the villain here, but the kind of fire they can create, that's a total game changer. So, is it enough to just add some new cameras and better sprinklers to our old ships? Or, to safely carry the cars of the future, do we need to completely reinvent the ships that carry them?